Good day everyone, my name is Dwayne Roxette Ibaliti and I'm going to present to you my application, which is an image classification app powered by the training model of Teachable Machine and the Flutter and Dart language. So my application is a condiment classification app which will be having a run through on how it works and how to use it. So my phone is connected to my laptop, which shows right here. So it is connected with Huawei Connect, which enables multi-screen. So what I do at my screen or at my phone will be shown at the laptop. So let's start by opening the app. So at the application, it shows condiment classification or the title of the app. Then next is the list of condiments that were trained at the application. Starts with ketchup, mayonnaise, mustard, soy sauce, and etc. So this widgets at the bottom can be clicked to show a small to show small text about the condiment. So let's say mustard. Mustard is sharp and zesty condiment with a bold flavor and ideal for hot dogs and meats. So the major part over here is the button which directs us to the logics or the back part of the app. So let's click it. Over here we have four tabs. So the first tab will be the scanner, or the first two tabs will be the scanner. So the first one is using the camera or via camera, which if we click at the bottom button, it will show the camera or it will enable the camera. And next will be the gallery, or the button at the bottom will enable the gallery, which directs us to the gallery and lets us select a photo, which will be used for scanning. The next part will be the analytics. So at the analytics, I have created the confidence trend of each day that it was used. So data will be gathered by the app and will be stored at Firebase or Firestore. Next is scans by condiment, which shows all the scans or shows all the classes in a table, which data will be plotted here and explained where how many times the class was called or was predicted. And at the bottom is the confidence tier, which shows all the scans and the percentage of per scan. So let's say the high or the 80% or higher shows here, meaning it predicted it pre- it predicted right or it predicted good. Medium, which has the 60 or 80, then the low, which is under 60%. So at the last part, it shows the logs, and here it shows the logo or the icon, which which shows which path it used. So let's find the other one here. So here it shows that the camera was used and it predicted fish sauce with 97.9%, and the bottom one is fish sauce again, which was 99.8 confidence rate, so on. So now I have shown you all the parts of the application. Now let's proceed on how it works or how to scan. So here you just click the button if you want to use camera, and at the gallery tab you click the button at the bottom, shows for gallery. So let's start testing the application. So let's start by testing all the condiments per app. So let's start with ketchup. So I opened the Google Drive that was provided to where we need to submit images per class. So let's start with this one. If we can make it bigger, I think we can make it bigger like that. So let's start capturing it, and it shows SketchUp, and I already saved this to uh, my gallery, which is this one, which shows SketchUp. So after scanning, it shows another widget or another part, which is detected condiment here. So after scanning each image, it will show the percentage of how it predicted. So this instance shows it predicted 100%, which is SketchUp. But let's say if I scan another image of SketchUp and it predicted 98%. So at this tab, it shows where the 2% is. So let's say the 2% goes to hot sauce because it looks the same, or it goes to fish sauce because some ketchups are more on the brown or the darker side, so fish sauce is more common to that, etc. So after that, we have tried ketchup with camera and gallery. Let's try another image of ketchup, which is this one. And shows another, it shows 100%. So let's try another class. So over here I have opened mayonnaise. There it shows mayonnaise with 100%. And let's try it with the gallery. There 100%. Let's try another image of mayonnaise. Here, mayonnaise, 100%. Now it shows 100%. So my method of testing it is trying to uh, test it first with camera and gallery with the same image, and after that another image of the same class. Now let's try with the other classes. Try mustard. Now it shows 98.6. Now where is the 1.4 going? So over here we can show that the 1.4% was at vinegar. Maybe because of the background, or maybe because it's mostly white and yellow, etc. Now let's try the gallery, and let's try another image.
Here, I am testing different classification classes in the app to verify accuracy, confidence scores, and UI behavior. As you can see, not all scans are 100% accurate because predictions depend on factors such as lighting, angles, and similarities between classes, which is expected in real-world AI models. This testing confirms that predictions, analytics logging, and error handling works as expected across all categories.
So I have tested all the classes, and it shows all the confidence or the classification rate of each class, and analytics will be held here. So today is Wednesday, so it shows a lot of scans or the tiers or the percentage rate was high because we used the app today. And for here, the scans went up, and over here, the logs were added also, and all the data were saved to the database.
3, 2, 1. So we have tackled the application and what it does and how you use it. Now I have to answer 3 questions that were given to me. So the first one is, how can your image classification app be applied to the real-world scenarios such as education, agriculture, and healthcare? What coding or architectural practices did you apply to keep your Flutter project clean and maintainable? And lastly, how did you ensure that the homepage layout remains responsive across different screen sizes? So in real world applications, this app works in several areas, such as in education. Students can scan condiments and immediately see predictions, confidence levels, and analytics. So it's a very visual way to explain AI concepts like confidence scores, misclassifications, and model limitations. Now, in agriculture or food industry, the same image classification pipeline can be used for quality control, like produce quality, checking produce quality, and verifying packaging labels. Analytics can show which items are often misclassified, pointing to pointing to lighting or labeling issues. So, and in healthcare or nutrition, the app can be extended into a dietary assistant where scanning food can surface nutritional warnings like if that a specific food or specific condiment is high in sodium or can possibly have allergens, and over time it can track how often certain food categorize how often certain food can categorize are consumed. Technically, image classify it's image classification, but pattern works anywhere where you point a camera at something, then it and want an instant label plus a long-term analytics. The second question, uh, I followed a architectural principle mainly in separation of concerns. So UI code is kept in screen folders, screens folder, then the business logic like the image classification and Firebase are in the services. That means UI just calls function and doesn't deal with the database details directly. So each screen manages its own state. So loading states and prediction results stay localized and easy to maintain. I also broke the UI into small and reusable widgets instead of a large build method, which makes the code easier to read, to test, and to update. All asynchronous tasks are async and await with proper error handling, so the UI stays responsive even if the model is even if the model is still loading or the network fails. So overall, this structure makes it easy to change or analytics without rewriting the whole app. Lastly, the last question about the responsive home layout. So for responsiveness, I avoided fixed sizes. So I based layouts on screen dimensions using media query. So sections automatically adjust on different phone sizes. So scrollable widgets like list view or draggable scrollable sheet are used instead of like fixed panels. which prevents overflow and lets users control uh, how how much content they see. So I also relied on Flutter's theme and text files for typography, which with consistent padding and spacing, the UI scales cleanly across the UI scales are clean across different resolutions. So in short, the UI adapts naturally instead of locking to one specific device. So I hope you liked my presentation, and that's all. Have a good day.